So, Vardhan sir is currently pursuing an MSc in computer science at the Chennai Mathematical Institute. He's fascinated by how logic, fairness, and strategy intertwine in mathematics and computation. His interests span algorithmic game theory, complexity theory, and probability, and he has worked on projects exploring multi agent systems, logic, and fair division. Sir enjoys leading sessions that spark algorithmic thinking, helping learners see how structured reasoning can solve surprisingly creative problems. At Roots, he brings a passion for uncovering the beauty hidden in algorithms and the joy of thinking deeply about how systems work. Over to you, sir.
Thank you for the introduction. So, good afternoon, everyone. I will first start sharing my screen before I start the lecture. Please, could you confirm if you can see my screen?
The screen is visible.
Okay, thank you for the confirmation. So, hello, everyone. Hope you had lunch. So, the title of the talk is Fair Division. Irrespective of that, we're going to start with a very general discussion about game. So, fair division comes under the category of game theory. So, has everybody played rock, paper, and scissors? If you have, please give a thumbs up. Right? Okay. And also, I forgot to mention there is a very small rule or format of this lecture. If you have any doubts, you can either put it in the chat or raise your hand. Otherwise, it gets very chaotic to resolve doubts and continue the session. I think that's fine. Yes. So, when you're playing rock, paper, scissors, can you guarantee that you can always win? Like, if not winning, at least you're not losing. Can you guarantee that? Let me write that. Can you guarantee that you never lose? Right. So, what is the format? You have scissors. Scissors beats paper. Paper beats rock, and rock is beaten by scissors. So, is there a way that you can never lose? Maybe tie is fine when both guys, like the two players who are playing, they're using the same element. Maybe if you're not winning, tie is fine, but is there a guarantee that you will never lose when you're playing this? Okay. Somebody raise their hand. Yes. AR Madhusudan. Maybe sorry, cannot pronounce your name, but yes.
Yes, sir. Sir, there is no there's you can't always guarantee that you can win or lose, sir.
Yes. So there is no way you can guarantee that you never lose, right? Is this clear to everyone? Like, can you see that? There is no strategy. There is no way that you can guarantee that you will never lose, right? Why is that so? Can anybody think of a reason?
It's a game of luck.
Yes. So okay, Shivansh, do you want to say something?
Sir, all the three are interconnected, no, sir?
Sorry, please could you repeat?
Sir, all the three are interlinked, no, sir?
Yes.
So,
Yeah, that is there. But the main idea why there is no way to guarantee that you can never lose because you never know what the other person will play. Okay, that is there. But in some kind of games, even if you know what other people are going to play, still you can guarantee something. But this is a game where you cannot guarantee, right? Unless you know that person. If you know that person, you know, okay, this guy always plays rock. Suppose you know this fact, right? Then you can guarantee that you will never lose, right? And with some other information. But in the general case, when you don't know anything about the other person, what they're playing, you can never guarantee, right? So this is a kind of a game where you cannot predict. So this is unpredictable. So in a game, what you have some players, and each player has some strategy. So in this kind of game, rock paper scissors, what are the strategies? Either you will play rock, either you will play paper, or you will play scissors, right? And what is the outcome? So if I play scissors and Nandika suppose plays paper, then I will get a point. I will get a 1 point, right? So that is an outcome. So what you have strategy. Okay, before that you have players, and each player has some strategies. And when you apply those strategies or you use those strategies, you get an outcome. Right? So these are like three components of any general game in general. So just a small question, just to see if you guys understood. Can you tell me in the game of chess, what are these three components? You can raise your hand. I will pick one of you. Yes, Shivansh, you can speak up.
So the players are the two players, the strategies are like the different moves or openings you do, and the outcome is whether it ends in a win, lose, or a draw.
Correct, correct. So one thing that you notice the difference between this rock, paper, scissors and chess is at every strategy that you play, you get an outcome when you play rock, paper, scissors, right? So if you play rock and another person plays scissors, you will get an outcome at that instant. But that's not the case with chess. Yeah, you have to keep on playing it multiple number of times till the game ends, right? So it's not a single step game, right? So that is also a difference. But majorly, most of the games are destructive. Okay. So before we move to fair division, let me just discuss. If anybody has any idea about game theory, not games, we just discuss about games, some components about games. If you have any idea like what could be game theory, what does it talk about, you can raise your hand. So let me see. Anand.
Yes, sir. So, like, you have a game which has some rules, and you try to find a strategy which results in like a higher chance for one person to win.
Right. That is one of the points. Let me hear from someone else as well. Manulan.
Sir, it's like a study of, I mean, like it's a theory about games and so algorithms about games and many others.
Okay, that's also right. Let me see if anybody. Nandita, do you want to add something on this?
When you analyze your opponent's moves and try to find a theory so that you can win or achieve a favorable outcome.
Correct. That's also correct. So game theory is a study of certain games, and depending on what you want, you try to find the best decisions, right? So there could be games where you don't know opponent strategy, right? You know, so in rock paper scissors, you know the other person will play rock paper scissors, but you don't know which one will play, right? You have to pick a strategy irrespective of the guy plays this rock paper or scissors. Can you win or not? Which doesn't exist. Which doesn't exist when you play deterministically, where I'm choosing a single strategy, right? So game theory is a study of games, and given on some condition what I want out of that game, I decide. I find a strategy or I make a plan or an algorithm of what to do, right? So that is the game theory. So when I talk about algorithms and stuff, it becomes algorithm game theory, but game theory is there in economics as well. So they don't talk about a lot of algorithms, they talk about it in a very different sense. So in computer science, we mostly talk about algorithm game theory, where we try to find the strategy that you need to play when others are playing some set of things, right? So there are different constraints which we will see later on. Yeah. So fair division is a subset of game theory in a sense that we will see later. But before we move to fair division, let's take another game which you might have seen. Do you guys know tic tac toe? Everybody, you can give a thumbs up if you know. Okay, I think everybody knows. That's great. So I will again ask the same question. So there is one big difference between tic tac toe and rock paper scissors. One difference is in rock paper scissors you play simultaneously, right? So at the same instant, both the person has to choose which element they want to pick out of rock, paper, or scissors. But with tic tac toe, that's not the case. There is player one, then there is player two. Suppose player one starts first, then player two plays, and it goes alternatively, right? So there is no simultaneousness. So one person has to play first, then the other person plays, right? So you can understand the difference, right? So there is a slight difference here. So suppose you have player one. By player one, I mean the one who starts the game. Starts the game. Now, can you answer this question? Like you don't have to speak up. You can raise your hand. I will try to pick up ones who have not spoken yet. Okay, Vikrant, do you want to add anything?
Yes, sir. If we cannot, then we can guarantee, because if we play perfectly, then we can either win, or if we plays perfectly also, it will lead maximum to a draw.
Hello,
Yes.
Vardhan sir.
Yes, Pratham.
Can you turn on your camera so we can spotlight you?
Sorry, actually, I have issue with my video system that happened with the previous lecture also. But you can spotlight my screen sharing. That is possible.
Okay.
Yes. Yes. So, what do you mean? Okay, Vikrant was telling me the answer, right? So, what do you mean perfect? Can you add on that?
Sir, if we place the game like correctly, like with a proper strategy.
Yes. So, we have to define that proper strategy. So, when you are the player one, so your answer is absolutely correct. When you are the player one who starts the game, there is a strategy that you will never lose. Though you might not guarantee that you will win, but you can never lose. You can either hit a tie or you will win, right? So the game, so I will tell you the solution. Maybe you can read it up online or see some videos. It's a very popular strategy. So you have to start, if you're the player one, you have to put your element cross or circle, whatever you start with. Suppose start with the cross, you have to put it in the center. Then there are strategies which will guarantee that you will never lose. So please look it up. So in tic-tac-toe, if you start, if you start the game, there is a strategy that you will never lose. What about player two? Player two is the one who plays after the player one has put his cross or circle. Is there a strategy that you can never lose? Yes, Shivansh, do you want to speak up?
Uh, so he has a strategy in which he never loses, but it may end in draw.
Yes, correct. That's why I'm asking a very specific question, and you are absolutely right. You can never guarantee a win, but you can always guarantee that you never lose for player two as well, right? So, the answer for this question is yes for both of them. But you have to be smart. So there exists strategy. There exists a way to play to put cross and circles on this grid so that both the players will never lose. They can end up in a tie, which is fine for us, but they will never lose. Right? Okay, so we talked about some very basic game theory stuff, and we saw different kind of games, right? So in chess, the thing is you play for multiple rounds to reach an outcome, but for rock paper and scissors, you reach an outcome at that given instance after, and you play simultaneously, which is not the case with tic tac toe and chess, right? So is there any doubt in among all these? Okay, the people who have raised their hand, is it related to a doubt or is it related to the previous question?
So it's a doubt. Like,
Yeah.
but there's another opening move that you can play that's just a corner.
Yes, there could be other strategies. I'm telling this is one of the strategies which starts where you start putting your element that you want to put like cross or circle in the center. That is one of the strategies. There could be multiple strategy which doesn't lead you to losing. Anand, do you have any doubt? ER Madhusudanan, do you have any doubt? Because your hand is okay. Abudaya.
Yeah, I cannot hear your voice clearly.
Okay. Can the volunteers confirm if my voice is clear or not?
Yes, sir, now it's clear.
Yes,
It's
sir.
clear.
Your
Yes,
voice is
sir.
clear.
Okay. Okay. Thank you for the confirmation. Yes. So let us move forward. So I set up all this because game theory is the parent of fair division. So a very simple question, just with the word fair and division, what do you think could be? What it could be? Please raise your hand if you want to speak up. Yes, Deepika.
Sir, I would say fair division is nothing but dividing, like, suppose you take anything, you divide equally among the number of people.
Yes, you are correct. There is just a slight issue. Okay, let me see what others also want to say. Anybody else? Yes, Kiara. Maybe I'm not pronouncing your name correctly. Please.
Kyra.
Kyra. Okay.
How much like the person like dividing as much what the person needs or is entitled to?
Okay. Okay, that's partially correct. Kamal.
So fair division is like
The opponent is accepting your proposal, means you are dividing the articles like that.
Okay, that is also partially correct. Okay, Nandita, anything do you want to add?
Dividing in proportion to the participants' efforts.
Okay, that is also correct. Anybody else? Okay, I think that's all. Yes. So collectively you were correct, but I didn't find a perfect answer, which is fine. I'm not expecting that because the talk is about it. So in fair division, you have two players. Again, you have players, which we call as agents. Now players have become, they are known as agents. This is just what we find in literature. So people who do research in fair division, but you can call them players, doesn't matter. So you have players, which are also known as agents, and there are some resources slash items. So in literature of fair division, the people who do research, they call agents and items, right? So fair division doesn't actually tell you anything. The thing is like, what do you call fair is very subjective, right? What do you might call fair in different situations? So this fair depends on context. So somebody said divide it proportionally, somebody said divide it equally, right? But it generally just depends on the context. It depends on context. So suppose a very small example. Suppose there are two sons. I mean, there are just two children, right? And the parents want to give away them some gifts. Suppose somebody is giving them a house. Okay, they have still not given. Suppose they have two things. One is house and one is car, and they want to give it to their children, right? So, but both the children don't have the same preference. Preference in the sense somebody likes house more than car, and somebody likes car more than house. Maybe somebody already has a car and the other one already has a house, so they don't prefer the same thing, right? So can you see this dividing them equally? So equally in the sense you cannot divide a house or a car. So maybe let me add house one, car one, house two, and car. Okay, because these items cannot be divided. They are like a single item, right? So I cannot divide them, right? So suppose these four items are there, and suppose I have children one, C1 and C2, right? And the first child already has house, and he doesn't want more houses. He's fine with it. And the second child already has car. He doesn't want car. Okay. So this dividing them equally will make them more happy, or depending on what they want will make them more happy. What do you think? This is just a philosophical question. There is nothing known as right or wrong here right now. So you can, yes, Deepika,
So depending on what they want.
what they want, correct? And let me hear Vikrant.
Well, I think depending on what they want itself, because like C1 would rather want a car than another house, and C2 would want a house than another car.
Correct. Malulan, what do you think?
Sir, like, yeah, but that would be the depending on what they want would be the way, but the fair way would be to distribute car and house, C2 to the first person and H2 to the second person.
Okay, fair. That is also correct. I mean, this is just a philosophical question. There is nothing known as what you call fair. So whenever we talk about fairness in this, at least theoretically, we define what do we mean by fairness, right? So we will see. We will see very simple examples of how do we define fairness in today's lecture, right? So let me come to some fairness notions. So notions in the sense, there are some ideas that we call as fair. So whatever we want, we call that fair when we are discussing that problem. So one kind of fairness is proportional. Okay. So a very easy example of this would be when you have a chocolate. So this is a sorry, a chocolate bar, and you have n kids, and you have to distribute it to them. And suppose everyone likes each portion of the chocolate, so there is no bias. Like I like the end of the chocolate, I like the middle part of the chocolate. There's no bias. They like it equal. So what do you think would be the best way to divide it? This is a very intuitive definition. This proportional notion of fair division is very intuitive. So anybody new actually, because same people are speaking up again and again. Because someone new. Yes, Asma.
Maybe like dividing the chocolate bar into n parts.
Correct. Correct. That is also correct. Arav, do you want to add anything on it?
No, sir, I had the same answer.
Yes, right. So when I say that everybody likes each part of the chocolate equally, you can just divide into 1/n and 1/n, right? That they would be happy, I guess. You would feel okay. I call this as something fair because I already defined. You have to tell what you mean by fair. Because in general, what do you call fair? There's no literal definition, right? When you want to work on. So one of the notion could be just divide equally 1/n, 1/n. But now I have in a different situation. It's very similar to the kid situation which we discussed where their parents want to give them house and car. Suppose I have a cake. This side is strawberry cake, and suppose this side is mango cake, right? And you have two kids. One kid has preference for mango, and other one has for strawberry. What do you think would be better? So I think the answer would be obviously the second kid should get the strawberry one, right? Correct? Okay, Kamal, do you want to say anything on it?
No, sir. On this point, first it should be given mango side, second student should be given strawberry.
Yes. Yeah, so that is the obvious answer. But it doesn't follow from the fact that what we discussed earlier, right? Because we just divided into 1/n, 1/n. So if I try to divide it equal in the sense, just with the portion size, not irrespective of what flavor is there on the cake, we just divide it equally. So suppose I just divided it into like this, right? This is also fine. This is also fair for you. But if I had divided like this, they would be more happy, right? Can you see that? If I divided like this, they would be more happy. That's a different case. So in proportional, you give okay, let me just write it. So whatever item that you have to cut or divide, you give one end of whatever that guy values that thing for, right? So for this guy, for the first kid, it might just value it 1 on this side and 0 on this side. And strawberry for the second kid, this is first kid, this is second kid. Second kid might value this side as 1 and this side as 0, right? So when I divide it like this, what is the value that the first kid gets? It gets half, and the second kid gets also half, right? But when I divide it like this, the first kid gets 1, but the second kid gets also what, and the second kid also gets 1. But with the definition proportionality, which I have already defined here, to just give 1/n of the whole value, you cannot guarantee they are getting the most. Can you see that? When I'm just dividing by 1/n, you are not guaranteeing in some way that they will get the best that you can give to them. Does that make sense?
Yes,
If there
sir.
are any, yes. If you have any doubts, I can discuss that. You can raise your hand. Yes, come.
So they are happy with their what they got. If the first kid got mango side, then he's happy now. So what's the problem?
They're happy, but I'm telling, if I followed the definition of just dividing into half, okay, sorry, 1 second. If I just followed the method of just dividing, suppose I divided it like this, they're happy. It's okay. They're getting at least half of what they value, right? They're getting at least half what they value. But if I had divided like this, just giving the whole mango piece to the first one and the whole strawberry side to the second one, they would be more happy, right? Do you see that?
Yes, sir.
But the proportionality, the way we have defined that doesn't guarantee that's the best one. So I define the best like they cannot get better than this for all cutting, right? So this definition doesn't guarantee you that in some way. So I'm telling, it just depends how you define fair. It's nothing known as nothing is best, better, or whatever. Yeah. So depending on situation, some definitions are better for you, but some are not. Okay, let's see. Okay, let me just talk about one more notion, and after that we will see one method to divide something equally within two people. So that's what we are planning for. So other notion is known as envy free. So this definition is very intuitive in the sense like it talks about the morals of humans, right? So if you have everybody like in within your siblings, suppose something is being divided, right? If something is being divided even though you have got some share, you would be jealous if your sibling has got something more, right? That is a very that is how humans are, right? So this definition comes from that thing. So however you have divided, if you're happy with your share and you're not jealous of the others, the other people are getting what others are getting, you call it envy free. So in the sense, suppose in the same example, if I had divided my cake, okay, let me draw it again because that has become messy. This is the mango side and this is the strawberry side, right? Suppose I had divided my cake like this, okay? And suppose the first kid got this side and the second kid got this side. So first kid liked mango, right? And second kid liked strawberry. So can you see, though they have got somewhat like half side, at least half of the cake, the first one will envy the second one. They will be jealous of the second one, right? Do you see that? And second one will be jealous of the first one because of this division. Though it's proportional, though I have done it proportionally, I have given half of the cake, right? Right? Still, the first one will be jealous of the second one because he has got more mango than me, and the second one will be jealous of the first one because he has got more strawberry. Right? So this definition is just that whatever thing that you have got, that is more than what others have got according to you, what you see, what you prefer, right? So you get, okay, not you get, everyone better right? So it's with respect to your preference, right? So if I just showed an example which is proportional, but it is not envy free because you will still envy the other guy because the other guy has got that flavor more than you, right? Does this make sense? This envy free definition. I'm not written anything formally. I'm just giving an intuitive idea, right? If you understood, then you can give a thumbs up. Otherwise, I'm happy to take down. Okay, great, great. Yeah. So one thing about fair division and game theory is that it's very accessible to people of any age compared to like any advanced topics that we read in computer science in colleges. This is one of the only field, I guess. Maybe there might be other fields, but this is a major field which is very convenient to teach to other people, which I feel is really good about it. Okay, so now we're going to learn about a method so that this envy free. So we have fixed the notion of envy freeness so that I get better than anybody else according to my preference. According to my preference, so I'm going to tell you a method where you have to divide something within two people so that nobody envies each other, right? So, okay, examples we have already covered. Cut and choose, right? So again, I'm going to take a cake example, which is a very popular example in literature. Suppose you have a cake, right? And again, there is one strawberry side and there is one mango side. This is a very simplified form of understanding this because cake could have various regions of various flavors, right? But this is a very simple form where it only has like two flavors and the regions are very separated out. I could also have something like this where mango is distributed here, 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 and strawberry is distributed here, here, and somewhere else, right? So it's not very uniformly distributed. It could happen, right? This is a very simplified form when strawberry is one side and the mango is on the other side. And you have kid A and kid B. It likes mango and kid B like strawberry. Okay. So what do you think would I'm not sure like how many people know this method. If you don't know, it would be really great if you can think of something which will help me divide this cake envy freely. Envy freely in the sense whatever I get, I'm not jealous of the whatever other people get, given that I've got that item that I have. Yes, Malolan.
So, if we give the whole mango part to A and the whole strawberry part to B, I don't think A should envy B because
Yes.
A got what they want.
Yes, correct. Okay, one thing I completely forgot to add, which is a very big thing. You don't know what B likes. Okay, so in this correct situation, I'm not the one who is cutting. They have to cut among themselves, but they don't know. Okay, A doesn't know. A doesn't know what B likes, and vice versa. Suppose this is a situation.
So then they could just cut half of the whole cake and take the piece, like
Like
if
this.
horizontally half. Yeah, yeah.
Okay, fair. That's a good idea. Anand. Anand,
So I had the same answer.
do you have the same answer? Okay. Shivans, do you have any idea to add?
So like we can cut it anyway such that both the parts are equal and the part that A gets has more.
Okay, that's also correct idea. Madhu Sudanan.
Sir, first they can cut up the to separate the strawberry and mango. Then they can cut half of both of them and give one piece of one strawberry and one piece of mango to both A and B.
Correct. So this part will go to A and the other part will go to B. Yes, that's correct. So the idea is what you do. A cuts the cake equally. But here equally doesn't mean the by size. Suppose there could be a case where, okay, this diagram is not helping at all. Let me change it slightly. Suppose strawberry side is really big and mango side is really small. Right? But irrespective that A cares about mango, he doesn't care about size of the cake. He only cares if he gets mango or not. Right? So A cuts the cake equally in the sense according to his preference. Right? So according to his preference, an equal cut would be something like this, right? Not this. This won't be a equal cut for him, right? Because one side has complete preference for him, the other side has no preference. He has no
The
preference for
doubt,
that.
sir.
Yes, yes, please.
Sir, can we like from that top part of the mango cake to the diametrically opposite point, can we do that type of cut? At least
This kind of cut?
yeah,
But
he'll get the full mango.
yeah, no. Okay, I'm telling you a method, right? So in this method, A cuts the cake so that both the sides have equal preference. He has equal preference for it. But if you can see, this side will has more preference than this side, right? Right? Okay. I have still not specified the whole algorithm, so it's correct. Okay, that idea is also fine. But I'm telling a method where you can do this envy freely. So everybody gets some portion of the cake so that they don't envy the other person. Right? So once A has cut it, so I will get two parts. Okay. And this is one part, this is the second part. Now it has only cut it. It has still not chosen. We have still not assigned a piece to someone, right? So what will B do? B chooses a piece. Right? Now B chooses a piece. Whatever is left goes to A. So can you see that whatever A gets, A does not envy the other person? Whatever A gets, I'm not talking about B. Whatever A gets, A does not envy the other person. Is that true? The way I have cut the cake?
Yes.
Yes, sir.
Yes, sir.
Right? Is it clear to everyone? If it's not clear, you can raise your hand.
So can you put the cut on that cake?
Yes, sure. Right? The way A has cut the cake, it prefers both the sides equally, right? it's not envying the whatever B has chosen, because whatever he has got, the other thing is also same, has same value, whatever he wanted, right? Now, can you guarantee envy freeness for the B, right? B has lot of freedom. B got two pieces and you have to choose one. Can you see which piece will he choose? What do you think?
Mango.
Mango. Okay, B preferred strawberry, but irrespective of that, because A has cut it, there won't be a case. It might not be the case that the whole thing is strawberry. There might not be the case that there is a piece which has only strawberry, right? It might not be the case the way A has cut it. So if you see, if A has choice to pick between two, he will pick the better one for him, according to him, not according to A. If he has two pieces, he will pick the one which is better according to him. If he picks the one which is better according to him, then just by it's directly you can apply the definition, right? Because this guy, suppose it's not this guy, sorry, this guy is better for B. According to B, this guy is more than valuable, more than this, then he doesn't envy, right? Can you see that? By definition itself.
Sir, so is that the strawberry part?
Okay, maybe
Yeah,
that might have caused an confusion. Let me.
What are the two parts, sir?
Yes, so these are the two parts which A has cut, right? Right? Equally according to him, correct?
Yes.
Okay, let me even change this slightly. Suppose the cut was like this. Let me change the color. 1 second. Suppose the cut was like this. It is still equally valuable for A, right? Can you see that? Both the pieces are still equally valuable to A because it has same amount of mango. Is it clear? Do you have okay? So I'm only doing the first step. So A has cut the cake equally according to him, and he okay.
B will choose the bottom part.
Sorry, cannot hear you, Vikrant. Could you be slightly louder?
So B will choose the bottom part and A will choose the top part, and still A
Yeah.
won't be angry.
Yes, A still won't be angry, and because B has chosen the piece which is better from him, he is also not angry because the other piece, if other piece was better, he would have chosen that, right?
Okay, sir.
Yes. So let me just repeat it once. So A will cut the cake according to his preference so that both the pieces are equally valuable for him, right? So here, the way I have cut it, both the pieces are equally valuable for him because both the pieces have same amount of mango, right? Now B will come. A only had the right to cut. He cannot choose. So B will come and choose. And which part will B choose? B will choose this bigger one, which has more strawberry, right? So he will choose this whole piece, and whatever is left goes to A. Because B was allowed to choose among the two pieces, he will always he will always take a bigger piece according to him, bigger, more valuable piece, right? And he will not envy the other piece. But because A had cut the cake into parts so that they are equally valuable, he also doesn't envy the other person because both the pieces were kind of same valuable for him, right? Do you see that? Similarly valuable for him. If you still have doubts, I am happy to discuss that.
I have a doubt, sir. What
Yes.
if A and B like the same part? What if A and B like the same thing?
If A will like the same thing, no issues. Okay.
Like if A and B both like mango
Yes. So let me draw that.
and don't like strawberry at all.
So suppose this is the mango and this is the strawberry side. Okay. If I cut it from the middle, right? Right. So now A will cut it like this, right? To make it equally valuable for him, right? A will cut it like this.
Yes, sir.
Now, which part will B choose?
Sir, any
Either
of the
two.
Any piece is fine for him. Doesn't matter. Any piece is fine for him because they are equal valuable for him also, right? So still you see, irrespective of okay, not irrespective the way A has cut and the way B is choosing, they always get better than what the other person is getting, right? You see?
Yes, sir. Sir, but what if A and B both like only mango and not strawberry? They hate strawberry.
I mean, they hate strawberry, but you cannot avoid. So either they can throw that portion of the cake. Okay, so this, okay,
Oh, okay, sir.
yes,
I
yes,
understood.
yeah. So, okay, I did not mention it very specifically. They have a preference. It's not like something they really don't like and they don't want at all. That's not the case. They can get something they don't like, but it's not like they hate it. I did not mention that very carefully. In the sense, there is nothing that they hate, but they have the very high preference for something. So they would really want that thing over the other. But it's not like if they get some portion of the other thing, they will be angry or something. That's not the case. Right? So this is a very simple algorithm, and this is the beginning of fair division. So this comes under the literature of cake cutting. You can read it up online as well. There are a lot of nice videos and resources to go over it. Okay. Okay. Now I will ask you guys to ask me a few doubts if you have. No doubt. So let me ask a simple question. Just give me a minute. Let me draw this cake. Okay, let me write A and B. So I'm given that A likes blueberry and A likes, I don't know which color to assign to it. Suppose this is guava, I don't know. So A likes blueberry and guava and B likes strawberry and mango. Okay, suppose this is given to you, right? So can you tell me how will they how will A cut this cake in the beginning? So I will give you some dummy lines so that you can tell me, otherwise there is no way you can draw it here. Let me draw some dummy lines.
So, sir, does A know that B likes like the
No,
strawberry?
no,
No, okay.
doesn't. Others they would have cut it perfectly. There would be no issue,
Yeah,
right?
okay.
Yes. So this is the first line. This is the second line, suppose. And by the line, I don't mean line. I'm just cutting the cake. It need not be a line, which you have seen in the previous example, right? This was not a line. This was a curve. This is the third line. This is the fourth line, suppose. So which one is the best cut according to A? If I follow the method which I've shared previously. So Nandita, do you want to say?
Third line.
Third line, you pick this one. Okay. Who else? Shivansh?
Sir, the fourth line.
Sorry, cannot hear you.
The fourth line.
Fourth line, okay. Abudaya?
So the third line.
Third line, okay. Kamal? Vikrant?
Sir, me, I also choose the third line.
You will choose the third line, okay. Madhusudanan?
Sir, I choose the third line and I have an answer of my own for this question, sir. Can I propose it after?
Yes, sir, please. Deepika?
So I'll go with the third line.
Okay. Ananta?
Same third line.
Third line, okay. Let's see. For some reason, the eraser is not working. Give me a second.
Sir, can I propose my answer now?
Just give me a second.
Line.
Okay, sir.
Yes. So one thing you have noticed that A only likes blueberry and guava, right? He likes only blueberry and guava. So the two pieces that he should divide in should have equal portions of blueberry and guava, right? But what's the issue with the third line? So a lot of people said the third line, but that's not correct because if you see this piece and if you see this piece, the other piece significantly has more amount of guava union blueberries, right? If you see, right? So third line won't work. It's not a good cut according to the method that we have learned. But fourth one is more optimal in the sense, though the size of the cake is small, but the portion that they're getting is slightly better, right? Can you see that? Yes, there could be better lines. I'm not saying this is the best line, but this is better than third. That's what I'm saying, right? So yes, Madhusudanan, you can suggest your answer if you want.
Yes, sir. First, I have about 5 cuts, sir. 5 different cuts.
Okay.
First, I cut out the purple part completely.
Okay.
Then I cut out the cyan part.
You cut out the purple part completely. Let me draw it for you. So you do it like this.
No, not like that, sir. Cut it out.
You completely cut it. Okay. Let me do it.
Then I cut out the cyan part.
You cut. Okay. This one.
Yes, sir. That line.
Okay.
Then I cut out the red part. So now all of the flavors are differentiated.
Correct.
Now I cut all of the flavors equally by half. Equally. All of the flavors equally. Using different lines.
Correct. So I divide it like this. Suppose this is like this like this, and this is like this. Correct.
And in that I give one purple piece, one cyan piece, one mango piece, one strawberry piece to A, and the rest to B.
No, you are still not. Yes, you cannot just give it right now. But yeah, that is correct, Al. So you have divided it equally, right? So what you said is actually equal in the sense for A. They are actually equal for A. So we have divided. Now B will choose it. B has the preference to choose it because A doesn't know na what B likes. It's something which we know. It's something which we know, right? So So now B has the right to choose it. So he or she will choose it, and whatever is that goes to A. And this method guarantees that nobody envies whatever they have got with the item which other people have got, right? There is a guarantee. This is an envy-free guarantee that we get with this method. Envy-free guarantee.
I think I also have a line.
Yeah.
But only I have a one line piece.
Yes, Vikrant.
Sir, like instead of so many lines, you can just make one big curve like thing. Like first we cut the blue part into half with one line, and then continuing that line you can continue cut. Sir, like you can cut one blue part into half, and then continuing that you can continue the cut the green part into half.
Yes, that would also work. So something like this, I
And
guess.
then yellow part into half. No, sir, not the green part. You don't need to like go through line.
Okay.
Yes, sir, something like that.
Yeah, fair. That is also works. That also works. What you said. Yeah, something like this, right?
Yes, sir.
Yeah, that also works. This is very similar to the thing that we have done previously.
Yes, sir. Like cut all 4 pieces into half by one line.
Okay, but okay, your answer is correct. So it guarantees envy freeness. But the method which I forgot his name, the person who suggested this cutting equally, who was that? Sorry.
Sir, Madhusudan.
Yes. So there is something more which his solution guarantees. That is, everybody gets equal. Everybody is okay. There is some more. Okay, maybe I missed it. We get something more which is not being guaranteed by the method which Kamal suggested, right? That was Kamal, right? Who suggested this thing like this? Who was that?
Sir, Vikrant, sir.
Okay, sorry. Yeah. So what Vikrant suggested, that gives B much more than what he would have got with the method of Madhu, right? So if you see this method gives B much more than what the other method would have given him when
No,
it is
sir, I
divided
meant
equally.
all four parts into half with one line. I meant.
Okay. So you had the same solution, but you're just dividing using a curve. That is also
Yes,
fine.
sir, using
Yeah.
one specific
Yeah. So if I had
instead
this
of wasting
solution,
the time.
right?
So, I had one way where A and B got exactly what they want.
Okay.
So you just like outline purple and green. Yeah. So like that
Yes.
A and A, but there will be no envying because B in the beginning, then A in the beginning didn't even want the mango and the strawberry, and it got its full portion of the purple and the blue. And B also just, and if B has to choose now, presumably he'll choose the mango and the strawberry because that's what he prefers.
Correct. But there was one issue that I mentioned earlier, that A doesn't know what B prefers and B doesn't know what A prefers, right? And they are cutting.
So I
These
have
are the
a
people who
doubt,
are cutting
sir.
and deciding. Yes.
Sir, can't A and B tell each other what flavor they wanted?
That's a genuine question. But this is just a setup. I'm saying this is just a setup.
No, but they know what they like themselves, right? So they'll
Yeah,
just
they know what they like themselves.
like
Yes.
themselves.
Yes. But the case would be if I just divide it like this, because I don't know what B likes, B might just pick this up, right? Even though I know that he likes this and this, maybe it could be the case like B likes this part, right? And he might just pick this and A is sad. Do you see that?
Yeah, then we'll have to divide each part into half.
Yes. So this guarantee which comes the MVP guarantee is when given the fact that the two players doesn't know what other people like, the other person likes, right? So it's best to divide it equally. The first person who cuts it, it's best for him to divide it equally so that whatever piece goes, he's never sad, right? He's not envying the other piece, whatever he gets, right? That is the guarantee that you're getting. So you need to remember this condition. A doesn't know what B likes and vice versa. This is an important condition on this algorithm or method, right? So if I divided this cake, each piece, like each flavor of the cake equally, like this is slightly worse than just dividing the cake like this, right? Even though if I've divided the cake like this, both the pieces are equally valuable for A, right? Both of these pieces are equally valuable for A, this piece and this piece, but A gets much more than what you would have got if I had divided the cake like this and this. So, okay, maybe I cannot draw it very properly. Sorry for that. And so this is the piece. Is the piece clear to everyone? Like, can you see the piece that I'm drawing?
Yes, sir.
Yes, sir.
Yes, sir.
Yeah. In this situation, B doesn't get as much as it would have got if A had just divided purple and the guava side, right? Yes. So there are different methods. So this piece doesn't guarantee you the best one. So this doesn't guarantee best piece for anyone. For A, obviously, it doesn't guarantee because he's cutting it equally. If he had the choice, he would have taken the piece with which he values the most, right? Which is not possible because he has to divide it equally. And for B also, it is not a guarantee the way we are cutting, right? Does it make sense?
Yes, sir.
Any
No,
doubt?
so can we generalize this and say that uh, like independent of A and B's choices, preferences, uh, the best would be to cut each piece into half.
Each piece into half.
I
Half.
mean each flavor into half.
Sure. For this situation, yes, correct. You are right. For this kind of situation where these kind of flavors which has been which are like placed like this, it is correct what you said. But in general, that doesn't work.
Sir, yeah, for the same situation, but the flavors can change.
Flavors can change also. This is a very simplified form of the actual problem. So the
Oh,
actual problem includes a lot of functions and stuff where you define value for this piece separately, right? So that gets very complicated. For the simplified version, whatever you said makes sense. That is correct. Any more doubts? Any more comments? This is what I wanted to cover today. I didn't want to get into some complicated stuff. So let me just go over what we did. So you understood games, right? So what are the three components of games? Somebody wants to tell me? I'm not going back to the page where I wrote it. Anyone? Yes, Vikrant?
Sir, I wrote it down, sir, already. I already wrote
Okay.
it. Like, wait, where was it? What?
Player
Player
strategy and
strategy
outcome.
outcome.
Yes.
Player
So
strategy.
you were in, yeah, it resonated the way you said, two of you. Yes. So a game has these three components. In a general game, we have these three components, but games might differ how they are planned, right? So rock paper scissors is very different from tic tac toe and chess. We saw that. And in fair division, we have some agents who wants to get items, right? Like items of some resources. But what do we call fair? That we have to assign some definition or meaning to it, right? So we saw two kind of definitions. One is proportional, where we divide it equally. Equal in the sense we divide it into one end of the whole thing. But in envy free, we have to divide in a way so that whatever piece I get, I don't envy the piece that the other person gets, right? To guarantee envy free, we saw an algorithm or a method for 2%. So this method is also generalized for more number of players. When you have like three players and you have this kind of cake, we have to divide it envy freely. Even for n players, it has been done, but it's very complicated. Even for three players, it gets complicated. For two players, it's very intuitive and very easy to understand. Right? So among this, do you have any doubt? Whatever we had done today, or any discussion that you want to start from here related to a game or something? No doubt? Okay. Everything is clear. If you everything is clear, you can give a thumbs up. Yes. Nice. Great. Okay, so that's all what I wanted to cover today. I wanted to go to a different algorithm, but I think it will get too complicated, so I'm not trying to do that within the last 15 minutes. But I'm very happy to do any kind of discussion that you want to. Not necessarily related to game theory or anything else. I'm happy to take that. And maybe volunteers just to tell the lecture is over. I'm done with the lecture. Let me see the chat if there are any doubts.
Sir, can you just introduce like what the algorithm that you wanted to go over?
For knife cutting, I will just give an overview. I'm not going to analyze it, so I can tell you. This is the moving knife algorithm. Let me take it to the new page. Just give me a second. Right, suppose you have n players. So this is for proportional. So the algorithm that we saw previously was to satisfy nv freeness. This algorithm is to satisfy proportionality. The first definition that we saw, proportionality. Right. So suppose the item that you want to divide is something continuous like this. Continuous is they're contiguous. So they're not like discrete items in the sense like you have this that we saw that car and house example, right? Where you cannot divide that house or car. But here this is just a chunk. This is a whole piece of suppose like a bread, and you can divide it like this. And you can also divide it into very small parts. That's also a possibility. Unlike car, if you just divide a car, it has no value anymore, right? So you cannot divide it, but you can divide suppose like a bread, right? So idea of this is suppose you have n players, and each of them knows what is the one nth value of the whole thing that they want, right? So suppose for player one values this thing as a1, and player two values this whole thing as a2, and they know 1 by nth value of this, right? Similarly, A3 by n and A4 by n, right? So what I do, I keep on moving the knife like this, right? I'm not cutting it, I'm just moving the knife. So whenever somebody says, okay, this is my 1nth, this satisfies the 1nth value of whatever I want, right? So I will cut the piece there and give it to that guy. Suppose A1 said, this is the 1nth value that this whole piece that I have cut, that is 1nth of the whole value of the whole cake that I wanted, right? So A1 will get that. Now I will keep on moving the knife again. As soon as somebody says, okay, this is 1nth of the whole thing that I wanted, right? Then you will give the piece to them. This is the moving knife, but this requires analysis. This is not very easy like the one that we have done before it. This requires some kind of proof writing and stuff to show that everybody gets 1nth of the 1 by n proportion of the whole thing, right? So this is the idea. I have not defined it very properly. So who asked this question? Okay, Malunan, was it very
Sir, but like this is clearly true, right? Because you're basically asking the person when how much you want, and then when the person says I don't want anymore, you just stop. So it's
Yes, yes. So whatever piece that the people is getting, that is 1n. That is correct. But you have to show that everybody gets it, right? You have to analyze that everybody gets it. Maybe the bread is over because of the 1n thing. Because everybody values the bread very differently, right? That's the issue,
oh yeah.
right? Are you getting that? Yes. Yes, Vikrant. Do you have any doubt?
Sir, but what if what if like at least one person doesn't have enough bread that he wants?
Yeah, that you have to analyze, and this will work. I never claim that that will happen. You have to show that, and this will work. I know that this works.
Oh, okay, sir.
Yes. Madhusudanan, yes.
So the if the breath has a finite distance.
Yes, correct.
So, for example, A1 wants, like, what should I say? From here, he wanted to leave 1 centimeter for all three of them. That will be really unfair.
Sorry, please could you repeat? So A1 for A1. If I start from here,
Yeah, A1 starts from here and just ends at just 1 centimeter from the end point.
like this. No,
Yes,
okay,
sir.
okay. Maybe I was not clear about it. So they have to say yes as soon as they hit the 1n of the portion. As soon as they hit the 1n. It's not more than that. Exactly 1.
Yes, sir. So then it will be unfair for other three people.
Yeah, but that's where you have to analyze this. So my algorithm is as soon as somebody hits the 1nth portion of it, they have to say yes and they will get that piece. This algorithm guarantees that everybody get at least 1nth of whatever they prefer. At least one.
Okay.
Your doubt is very genuine. That can happen, but this doesn't happen because of the algorithm itself. I am not analyzing it, but that will happen.
Okay, sir.
Yes.
Maybe there should be like one rule where, for example, because if there are like n players, one and yeah, okay, sir, the same things.
It's fine. It's fine. I mean, this is open to discussion. There is nothing right or wrong here, right?
Okay, sir. Thank you, sir.
Thank you. Any more doubts? Anything else that we can discuss? Okay, then I think it's the right time to end the lecture. Herav, are you there?
Yes, I believe vote of thanks will be there now. Thank you, Vatanana, for taking time out of your busy schedule in order to take us through fair division algorithms, take us on a journey. The class was very fascinating and interactive. I'm sure everyone enjoyed a lot and learned as well.
Thank you, Vera. So, what are we supposed to do now?
I think the class will be over now. Your
Okay,
notes have been done.
can we leave the lecture, the meeting?
I think so. Yes.
Thank you everyone
Yes.
for joining. It was great discussing with you all.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank
Bye.
you, sir.
Thank you, sir.
Thank
Thank
you, sir.
Thank you,
you,
sir.
sir.